All right, guys, problem 8. Problem 8 says the medical research lab is testing a new drug on a patient, and the amount of the drug remaining in the patient's bloodstream T hours after the drug is administered can be modeled by this equation. So the first thing we should do, of course, is type it in our calculators and get a good idea of what we're looking at. All right, so when we graph it, it's a cubic function, and it looks like the only relevant part of this graph is quadrant 1. Quadrant 1 says that to start with, if you take a look at what the y-intercept would mean, since the constant term is 8, it means we would basically be starting, let's say this was measured in milligrams, then we would say that would be 8 milligrams to start with, and then when is it eliminated? At 2 hours, it appears. So we can verify that it is 2 on our calculator, and it is. So it would be 2 hours. There's none left in our system after 2 hours. Then it says identify and discuss the other roots. Well, based on the graph, what we understand is that we should have 2 imaginary roots. So let's take our real solution of 2 and do synthetic division, making sure that if any were missing that we fill in zeros, but they're not. So negative 2, negative 4, 2, 4, negative 4, 8, 0. And this is negative 2x squared plus 2x minus 4 equals 0. Or, of course, we could use t since they have t instead of x. To get started, we could go ahead and use quadratic formula, or we could complete the square. If you want to go ahead and use quadratic formula, I did it a different way in class. I factored out a and all that, but if you want, I'll just show you this method here with using quadratic formula. So our a term and our b term and c term are identified. We always find our discriminant first. So that would be 2 squared minus 4 times negative 2 times negative 4. Got to be very careful and not miss any signs here. So that would be 2 squared minus 4 times negative 2 times negative 4, and we get negative 28. So then when solving by using the quadratic formula, the opposite of b plus or minus the square root of your discriminant, all over 2 times a. This point, we have negative 2 plus or minus the square root. We know we're going to put I out front and make our negative 28 positive, but the factors of that are 4 and 7, of which we can take the square root of 4. I'm sorry, we take the square root of 4 and we get 2 rather. Sorry about that. It breaks down to 2 and 2. That's what comes out. So 2 square roots of 7 over negative 4. Please make sure you simplify this. All these are divisible by 2. So that's 1, 1, and 2. But remember I taught you, if you write it out, 1 plus or minus I square roots of 7 over negative 2, that you actually switch your signs. So that would be plus, and that would be negative. Just think of it as it was a positive divided by negative, which is negative. So our final solution here would be x equals negative 1 plus or minus I square roots of 7 all over 2. But in terms of discussing this, we should understand that our t, or I should say t instead of x, time is our independent variable here. So when we're solving, we're actually solving for time. 2 hours makes sense, but an imaginary amount of time is not relevant, or it just doesn't make sense. So we can say that in terms of discussing the other roots, the 2 imaginary roots, it's not how you spell imaginary, are just simply not relevant, in terms of time, or they're not relevant for this particular polynomial model. Okay? So number 9, we've talked about these before, So I'll go over them again. Please make sure you have the correct answers. Memorize my answers if you have to for these next problems. It says describe the relationship between zeros and factors, and I did this on your last test, so I'm going to kind of squeeze it in. So if polynomial p of x has a factor x minus c, then c is a 0. Likewise, if p of x has a 0 c, then x minus c is a factor of p of x. I should say up here also of p of x. Then it says give an example. So you could say if x minus 3 is a factor of p of x, then 3 is a 0. Okay, if x minus 3 is a factor of p of x, then 3 is a 0. Next, it says to describe the fundamental theorem of algebra in your own words. Remember, the fundamental theorem of algebra basically says that the degree of a polynomial tells you how many complex roots you have. So we'll say a polynomial p of x with degree n for number of roots, has n complex roots. These roots can be real or imaginary, but never exceed n, which is your degree, okay? So the most zeros you can have is equal to the degree. All right. Next, says describe the irrational root theorem in your own words. Make sure you use complete sentences and give an example. So the irrational root theorem says that if p of x has an irrational root, its conjugate is also a root. For example, square root of 3, negative square root of 3, or anything similar to that, okay? 12, describe the complex conjugates theorem or imaginary root theorem in your own words in complete sentences and give an example. You basically word number 12 like you do 11, only instead of irrational, you say imaginary. So if p of x has an imaginary root, its conjugate is also a root. For example, if x equals, well, I'll just say this. If you have 2 plus 3i, then 2 minus 3i is also a root. Next, describe how you can determine the number of complex, then real or imaginary roots a polynomial function can have. A polynomial p of x with degree n, so this basically ties into your fundamental theorem of algebra, that it has n roots. So if you can better explain it, use an example, but you've got to explain that part. And then you might want to just indicate the total made up of the real plus imaginary will equal the degree. So give me 2 examples. And I asked for an odd degree and an even degree polynomial. So you don't have to make it too fancy. You can just say p of x equals x to the 5th power, and then list your possibilities. So you could say p of x equals x to the 5th could have 5 real, and then 0 imaginary. It could have 2 imaginary and 3 real, so 3 real, 2 imaginary. And actually separate these with colons if you don't mind. 5 real, 0 imaginary, 3 real with 2 imaginary. If it has 4 imaginary, you would only have 1 real. Okay, and I'm not going to write it. You'll have more room on your test, but come up with another example with at least x to the 4th, if not higher, like x to the 6th, x to the 8th, or whatever, to list your possibilities. All right, the next video will cover problem number 14.